Welcome back to the next video in my series where I'm going through the challenges in my book, The C Sharp Player's Guide. We're going to jump ahead again to the next boss battle here. There's a lot of challenges we're skipping over, but the last one we were doing was all of these in here that are the catacombs of the class from the point down through tic-tac-toe. So we're skipping a few here, packing inventory, labeling inventory, old robot down here. And we're going to jump down here to the fountain of objects. This number of experience points is the biggest single number of experience points for a single challenge out of all of them. The final battle down here, when you add up all these, is higher. So we're gonna start with this fountain of objects. The challenge asks you to, well, I'll jump over to it, but these here, the small, medium, large, pits, maelstroms, amaroks, getting armed and getting help are all building on this foundation. So this is really the first challenge that we've had where you will have to build something and then something substantial and then build upon it. We've had a few other challenges in the past that had something relatively small and then we made some minor improvements on it. But this one's going to be much bigger. I do want to say, for the sake of clarity, I'm not trying to recreate the solution that I have on the website. That's just code. It's been, like, at this point now, it's probably been, I don't know, several months since I really thought about the Fountain of Objects challenge. So I'm hoping that I've forgotten a lot of details and I actually won't just recreate what I did before, that I'll do something different. I think in this video, we'll probably only focus on this main Fountain of Objects challenge, and in other videos, we'll get to these other challenges. So I'm gonna just click on this and jump down to it. And before I do, I want to scroll up a little bit here and just kind of recap some of the information here. Mainly this one. You don't need to complete every challenge listed here. This is a choose your own adventure part of the book. So there's two ways to proceed. Option one is to complete the base game, which is what we're going to be doing today, and then 2 expansions. Option two is to go online and find my solution that I've provided on the website and use that as the starting point and then do 5 of the expansions. And it looks like I've got a typo there that I need to correct. It's amazing, even after doing so much revision, that something like that can still get left out. Let me bring this over here. So I just want to show you this in case this is the path you want to take here. If I come in here to solutions, of course, I can pick 4th or 5th. They're both about the same. There is, let's see if I can find it really quick here. Maybe just this, this the Fountain of Objects, that you could start with this code. One of the things, like this code, I'm trying to not look at this code too much right now because I don't want it to give me any answers for what I'm about to do. But you could, like this, what I do remember about this version right here is that I had built a bunch of infrastructure that would make the future challenges, these others that build on it, just a little bit easier to manage. So if you're having a hard time with like object-oriented design, it might be useful to pursue that path instead, because you'll see how I set things up, and that gives you a chance to work with an object-oriented system, and figure out where to like extend it and things like that, which is a very important skill to have in terms of being a programmer, but it doesn't demand that you do literally everything from the ground up. So it gives you a chance to get a glimpse of what it could look like, and to work in it, which I think is really good experience. I will say though that it feels like most of the people who I see report like show their progress in this challenge tend to do the base themselves, and I think that's a perfectly fine approach here too. So like I said, there's a path, and you can pick which way you want to take, either the base game and then pick 2 expansions, or kind of take the solution that I've got and do 5 expansions. And yeah, so having said that, I do want to kind of give you a little bit of a feel for what this thing looks like. And I'm going to do that by, I don't need that anymore. I'm going to jump over here. So this game is it's not exactly the same as Hunt the Wumpus, but it does have a lot of similarities. So this is a game that was a very, I don't know, it's used a lot for like in teaching AI and some things like that. It's an interesting concept based on like what it how it works. So let me come to here. So this is an example of what this looks like, although in our case we aren't necessarily going to be drawing the map. So you're and in the original Hunt the Wumpus, like you can see here, like it's all text based. So this shows a map that we wouldn't necessarily have, and it's also got like some buttons to push instead of what we'll be doing, which is all command line. But so you can kind of get a feel for how this game works. So you're at 4-4. So the goal in this game is we've got some arrows. Does it tell us how many arrows we have? Oh, right there. Arrows remaining 5. So we've got some arrows, and our goal is to shoot. We can move around and we can shoot. And wherever in this version, our goal is to shoot the Wumpus. In the game that we're gonna make, the goal is not to do anything with the Wumpus necessarily, but you could avoid it if you want. The goal is to get to a specific room safely and then get back to the entrance. So what we'll be building is a little bit different, but I think you can still imagine how this will work. So there's a grid, and you can move around in the grid, and like this tells you where you're at. And eventually it gets to a point, maybe, oh, I found an arrow. It gets to a point where, there, you feel a breeze. So when you feel a breeze, let's see, then you know that there is a bottomless pit nearby. Now, in this particular implementation, I couldn't tell you. So I couldn't tell you if diagonals also count for the pit. But so, given that we didn't, like if I come back here, there is no breeze. I know the pit's going to be over in here somewhere, and it might be just if it includes diagonals, then the pit could be any of these. If it doesn't include diagonals, and the pit's just one of these 3. But so I actually know that I can go up from here and be safe, or I can go down from here and be safe. So I can maybe navigate a little more and see. So like at this point now, I know like I'm not sensing any of these things. So like let me take a step back. Yeah, like this says there are several hazards. There's a bottomless pit, and you can tell because there will be you'll be able to feel a breeze. You can't see what's in the room when you go into it. It's all dark, but you'll be able to feel a breeze. This one has a colony of bats. You'll hear flapping nearby, so you can hear these hazards from the room next door but you don't know which direction you're hearing it from, which is the catch of the game. So there's a fearsome, hungry, unbathed Wumpus. You'll smell it nearby. So our goal is to find the Wumpus. And let's see. So I guess I know if I'm here, I know this place now is safe, so I can come over here. And now, given that this place says you feel a breeze and this place says you feel a breeze, there's a pretty good bet that it's adjacent to, like it's probably here or here. So I'm going to take a risk and go up because I think this is safe. And it was, and now this is safe. So we don't know where actually, given that we're here and we don't feel a breeze, the breeze is going to, let's see, the breeze is the pit. This right here we know is the bottomless pit. And now that we're right here, we're also smelling a Wumpus. So the Wumpus is, given that this is, the Wumpus could be in this room too. No, we would have seen the Wumpus here. So anyway, you kind of get the point. Like we're supposed to just kind of explore. So now I think the Wumpus is, given that let's see if we can just explore this a little bit. Like I think that pit was where the breeze is. I think the Wumpus is probably right here, but it might be here. And I actually, at this point, we could just shoot. Nope, it wasn't there. So it's probably this one here. So let's shoot down here. Missed. What? I don't know where it is. Did I shoot in the right direction? I must not have. I don't know what I did, but that time when I pushed it, now it says you in. All right. Anyway, so you get the gist. Like I said, the original game here was a little different. Like it wasn't a grid. It was on, like you can see like the arrangement of rooms. It was arranged on a dodecagon. We're gonna keep things simpler. Not that you couldn't do it that way, but our version, Fountain of Objects, is definitely simpler. All right, so with that kind of background on kind of Hunt the Wumpus, which is not exactly the game we're making, but this game is a derivative of that, basically. Now we can dive into this. All right. And yes, this point here, this is a tough challenge. And you should expect it to take some time. We're now at the end of part 2. Part 3 ends up being just kind of a scattered random collection of advanced features. I mean, I wouldn't say super advanced. They're features that most C# programmers know or should know. But they're not like this like cohesive thing. Like from here on, you can like go through those and like look around and say, oh, I'd like events, I'd like delegates. That sounds interesting. Lambdas, query expressions, what's that? And to be able to like kind of pick and choose the parts that are interesting to you and kind of learn those tools as you need them. But we're kind of at a very important point here, and that is we've done all kind of the procedural programming stuff in part 1, and we've done all this like object-oriented programming stuff. So we now have pretty close to a full set of tools in terms of object-oriented programming that we can apply to this challenge that's meant to be pretty tough, and it is, and I hope the experience points that are on here reflect that. All right, let's get into this. The Fountain of Objects is a 2D grid-based world full of rooms. You can see this picture down here that illustrates that. Most rooms are empty, but a few are unique. One room is the cavern entrance, and another is the fountain room containing the Fountain of Objects. So our goal is to get in here and use this thing that we have. I don't remember what it is. It's in the book. This thing that you're supposed to use to like restore the Fountain of Objects that should restore life to all of the entire island, continent, I don't know what you want to call it, this big landmass that we've been on for all of part 2 as terms of how the story goes. So the goal is where we start in the entrance, and we're going to go to the fountain room and turn it on, and then we're going to leave. So we're going to have to be able to maneuver from room to room to find it, and we need to do it without running into any sort of hazards. This unnatural darkness is what makes it so that we can't just like turn on the lights and just see everything, that we have to like trust our other senses, what we can hear and what we can smell and things like that. And yeah, so this is the basis for other things. So we're actually gonna mostly ignore, for the sake of more entertainment value here, we're gonna not worry too much about these other challenges that build on it yet. We'll deal with adding those in later. But so the world consists of a grid of rooms where each room can be referenced by its row and column, and it gives us, north is up, whatever. So the game flow works like this. The player's told what they can sense in the dark, what they can see, what they can hear, what they can smell. The only thing I think we're going to be able to see is that we're in light coming through the entrance. So that's the only thing we'll actually be able to see. But we'll be able to hear stuff and smell stuff. So we'll be able to sense things around us based on what's, where we are in the room. And then the player gets a chance to perform an action by typing it. And let's see, does that? It does illustrate that here. So you're in the room at this location, and this tells us like what we're sensing. So we're in the cavern entrance, and so we see light coming from it. We hear water dripping in this room. The Fountain of Objects is here. So it tells us what we can do, and then there's this what do you want to do, and then we can type in a command, move east, enable fountain. You can see the commands that are here. Move in a direction, enable the fountain. Let's see. The player, let's see. Yeah, so that's kind of the main loop. So they type in an action, and then their action is resolved. The player moves, the state of the game changes, checks for win, loss, etc. Then the loop repeats. Most rooms are empty, and there's nothing to sense. The player is in one of the rooms and can move between them by typing commands like move north, move south, move east, move west. The player should not be able to move past the end of the map. We'll have to make sure we do that. The room at 00 is the cavern entrance and exit. The player should start there. The player can sense light coming from outside the cavern when in this room. And it gives us this text. I don't think you should feel like you need to stick to that religiously. It's example text. The room at... So this tells us exactly where... Does this tell us... It is a 4x4 room to start. And the room at 00 is the entrance. The room at 02, so it's only 2 spaces over, is the fountain. Of course, the player doesn't know where that is. So this one thing this is doing is this isn't like this like decrees. The game is going to look the same every single time, which I think I think that's fine. I think it'd be more interesting if you could randomly generate this somehow. We don't have, I mean, we've talked about this before. We don't have the tools for randomness. Not that they're that hard, but and we'll get to that in very soon. The last level in part 2 does introduce a handful of objects that are useful in a lot of cases. And if you if you jump ahead, you could jump ahead right now, read all of those, and then come back to this if you want. And have that kind of these extra tools. It doesn't fit in line with the story very well, where you're supposed to get all those tools when you when the fountain of objects is flowing. But it's fine. You could jump ahead and read that if you wanted to, and then you could maybe randomly place the fountain room at the entrance and stuff. Let's see. The fountain can either be enabled or disabled. The player can hear the fountain, but hears different things depending on if it's on or not. So you hear water dripping in this room, so that's if it's off. And then this is if it's on. So the fountain's off initially in the fountain room. The player can type enable fountain to enable it. At one point, I had a command for disable fountain. There wasn't really a whole lot of value in that though. So, but if you type enable fountain and you're not in that room, then it shouldn't work. You should be told. So the player wins by moving to the fountain room, enabling the fountain, and moving back to the cavern entrance. If the player is in the entrance and the fountain is on, the player wins. So actually, in this case, what we've described so far, and I think we're just about done. There actually is currently no way to lose this game. You'll fumble around until you eventually find the fountain, and then you can turn it on, and then you'll eventually fumble your way back to the entrance. And so as long as you keep playing, you will eventually win and you can't lose. The other challenges ensure that there is a way to lose. But so we're not introducing any actual hazards yet. Let's see. Use different colors to display the different types of text in the console window. Okay. An example. So this is just an example. And then there were a couple of hints down here. So you may find two-dimensional arrays helpful in representing a 2D grid-based game. You do not need to solve the entire problem all at once, and you do not have to get it right in your first attempt. Pick an item or two to start and solve just those items. Rework until you're happy, then add the next item or two. So let's see. With all of that aside, I do think to kind of continue with tradition, I'm going to come back in here and I'm going to do some CRC cards for this. We did these in earlier challenges. The book has a whole chapter that's talking about object-oriented design. I want to say it's 23, but I might be remembering that wrong. It's about there. And it walks through how to use CRC cards. So I'm not going to, and we've already covered the basics of that here in video form too. So I'm not going to cover the details other than to say once again that CRC cards is not how I typically work. I usually just sketch stuff on a whiteboard that I've got. I don't have a whiteboard on the screen, so I can't do that. And I think CRC cards are a meaningful, they're a useful tool. So, and again, I'm using Adobe Illustrator here. I wouldn't recommend that everybody go buy Adobe Illustrator to do this. It's not I honestly don't even recommend you use a computer to do this. I generally recommend you do it in paper form. But anyway, let's get started and start thinking through the cards that we're going to have. And I moved the description just off to my other window so I can still see it, but you won't be able to. But let's walk through these and start thinking through what could this design look like? Like what kinds of classes are we gonna likely have, and what are each of them going to be responsible for? Let's see. So the world consists of a grid of rooms where each room can be referenced by its row and column. So the first thing that comes to my mind on that is I feel like we are going to need a class that represents that grid of rooms. The world consists of a grid of rooms, and I'm going to call that the map class. It may not this doesn't draw the map, and maybe grid of rooms is just as good of a name for it, but I kind of like map. It's a little more evocative than grid of rooms. So I'm gonna stick with that name for now. And then this is going to keeps track of what rooms are what? Keeps track of the rooms in the world. Let's call it that. Um, so let's see. I think that's a good start. So I'll scoot that over here a little bit and make the next card. So this also says, so this gives us some definitions like north is up, east is right, down, south is down, and west is left. I do think that that's an enumeration. So I think we're going to have like a direction enumeration. I'm not going to make a card for the enumeration, but I think you could if you wanted to. I do expect that we're going to have it though. The game's flow works like this. The player's told what they can sense in the dark. Then the player gets a chance to perform some action by typing it in. Their chosen action is resolved. So this is introducing a lot of concepts fast and furious. So something needs to be responsible for tracking the game's flow, right? And as we've seen in several of the other things that we've made, there usually ends up being a class that's like represents the game as a whole. And in the past, like that's the class that has done. That's the class that's done like the game flow. That's managed like walking through this process. So I think we're gonna do the same thing here too. I think that makes sense. And this will run the game loop. That's what it's often called. So this is the part like in the line says the game's flow works like this. The player's told what they can sense. The player gets a chance to perform an action. Their chosen action's resolved. And then the loop repeats. So you know what? Okay, I do still have that. So what I'm going to do here is indicate sensed stuff. Ask player to perform an action. And resolve player action. So I'm that's the loop. I think that summarizes it pretty well, other than like we're missing all sorts of things here. Something's got to figure out what stuff the player consents. Like for whatever for whatever I'm just sorry, my brain's jumping around here a little bit. So we do like like I said, that one line covers a whole ton of ground, and so let's just start thinking through how we might represent it. Like the player's going to have to be somewhere in this world. So they need we need something that knows where the player is at. And so I think it makes sense for there to be a player class of some sort. Just thinking out loud here. So this would, at a minimum, knows where the player is at. And I think, like, I feel like this thing needs to know about both the map and the player. And I do think there's only going to be one player and one map as far as this goes. So this is going to have to know where the player is at. And then there's a question here of player input. Like the player's going to type in a command and then run it. So the question, so this ask a player for an action. Where should that the player's choice, the player's action? How do how are we going to handle those actions, and how are we going to handle like who's gonna talk to the user using the console window and get that the choice from the player. So the map class doesn't make sense for that. I do think it could make sense for this, like, to say the player class is going to do that. But I kind of like I kind of like the idea of this player class, not like this just represents the concept of the player's character within the game world. And I don't know if I don't think it's unreasonable to put input, like the player input, into that player class, but I actually think that it makes quite a bit of sense to have like a totally separate player input class. So I'm gonna just do that. And we've sometimes skipped this and sometimes included it. This is going to use the console window to get an action from the player. One thing I do like about separating out the way the human tells the player where to go from the like representation of the player within the game world. One of the things I like about that separation is it allows us to swap this player input for something else without having to have a big impact on the rest of the game. And again, that's a good rule of thumb for when to make another class. Does this have a different reason to change? Like, is this something that I might want to swap? And at this point, we know about interfaces and abstract classes and things like that. So we could imagine having a player input that is console based, but we could also imagine having a player input that is coming from across the network. We don't have the tools to do network programming yet, but that's a possibility. We could get it from the network, or we could make an AI player for this, and all we would have to do is swap this out. So as long as we make it swappable, then we'd be pretty good. So, like I said, by separating that out, it allows us to change this part without affecting the rest of the game, which has its benefits. All right, let's see. So I think I like that better. And now we've got this concept of actions. This thing, like, so how is this guy going to convey back up to this guy that, well, so okay, so let me put it this way. Oops, didn't mean to dig into that. This, so we can, like, this can get an action from the player, so this guy can just ask the player for an action, or maybe so, but something has to do this resolving the player action. And we know about at least 5 actions. There's 4 move actions: move north, south, east, west, and enable the fountain. And something's got to be able to handle all of these different action types. So that responsibility could live in a bunch of different places once again. So let's think this through. It could live on the map. We could say, hey, here's the action. The user typed in some string, and here's the string the user typed in. Do what you want with it. But I actually think, like, the map is only, like, it right now, at least, this doesn't actually know about the player. So if we are changing something about the play, like if this guy is executing the actions, he won't have he won't have access to all the information that he needs to resolve an action. Again, we could have this player resolve it, but like most of these changes that are happening, I don't know. I mean, maybe it goes there, but I just like some of the things like the enable fountain doesn't really feel like that should be something that the player should be doing. We could just have player input handle it directly. This guy, and if that's the case, he would probably have to know about the fountain of the game, the main game, so that he can do stuff. After all, he's the one who gets that action. So in that case, like, both of these just kind of get squished together. I wrote them out as 2 separate things, but both of these get squished together and just they just become a part of, hey, player, do your thing. It's your turn, make a move. And that, I think, is a potentially a reasonable way to do it. I do kind of like this other idea, which is something that we actually saw in an earlier challenge that we haven't covered in videos yet. That is like to have like a set of like an interface that's like uh, like a command, and then different implementations that handle that, like when that they can be told to run, and when they run, they will just do whatever change they need to do. So, like, I mean, let's just brainstorm that just a little bit here. Like, let's suppose we had we made, come on, it's not working very well. We had like an action, and maybe this is an interface. Let's tentatively say that is an interface. So this represents a concept of an action. And then what we could have, so this is an action interface, and we could, for example, come over here and say, like, there's going to be, like, there's the possibility of having like a move action, and this would causes the player to move in a specific direction. Let's suppose, so we could draw pretty broadly. We could imagine any, like, as long as you have access to this game, Fountain of Objects game, that action would be able to do anything that it can, anything, like it has access to the whole game. It could manipulate the game's current state in all sorts of different ways as long as it has it. So we could have a move action. This would have to know about, so this would also have to know about the game. And we could have a move north action, a move south action, a move east action, a move west action. I don't think that'd be bad to have each of those different actions. So maybe we'll do that, but also there's a enable. So, oops, what did I just do? Enable fountain action. Enables the fountain. This would also have access to that, to the game, so that it can get to the whatever. Yeah. So we could have, maybe these are two different implementations of this, and so maybe this, this will take the user's input, whatever they type in, and either make a new move action or make a new enable fountain action, and then return it. So the fountain of objects would say, "Hey, player input, what's the plan here?" This says, "Oh, well, I've talked to the user on the command using the command line, and they wanted to do this move action." So this guy creates the action. This game then says, "Okay, hey, action, I would like you to run." And you know what? I'm gonna sometimes the best tool for like mentally exploring stuff is literally the code. I mean, we as programmers we spend so much time in code that sometimes it's just easier to do that instead of in this. And you should not be afraid to write code in the exploratory phase of any of this stuff. So I like, just to sketch this out really quickly. Like what we're kind of talking about here is something like, yeah. So this guy has a run method, and somewhere in here he's gonna, again, we'll revisit this in a little more detail later, but like this guy will have a player, And so he'll down in here, he'll say, hey, player, um, get the action, and he'll have and he'll take, I'm just going to say return null for now. It's not going to like that, but like I said, I'm just sketching it out here. So yeah, something like this where this thing says, hey, player, get the action, and then it says action dot execute, passing in itself, which would allow, oh, and by the way, this was supposed to be player input, wasn't it? Not player. We'll fix that later. Fine, we'll fix it now. Yeah, so now in this case, we could just pass in this. So if this has like a access to the map, then some action down in here, this guy would be able to do something like game dot, do something with the map. So like it's able to get in there and do stuff. So that's the gist that I think I'm aiming for here, is basically we'll have so this guy, when the time is right, he'll say, player, I need you to figure out what the human driving this actually wants. Or maybe, like I said, that's what it'll be for now, but it could be, what is the AI that's doing this? What does the network say? Like whatever that is, tell me what action we're supposed to run. And he returns that back to here, and then this guy says, okay, action. And he just knows that it's some abstract, he just knows it's some abstraction. He doesn't know what that action is going to do. The Fountain of Objects game has no notion of what that action is actually going to do. But he's going to say, whatever you are, action, it's your turn. Make whatever changes to the entire world that you need to. So and I guess we've kind of said this guy is going to run the game loop, but he's also going to have all that information. He has the map. He knows where the player is. And you could imagine having, I don't know, anything else, like as long as it's accessible from kind of this route, any action will be able to reach back over to this guy because he's given that and run it. All right, so we fleshed out a whole ton of classes here in CRC card form. This sensed stuff thing is like we might actually do something similar to this with senses. Now we don't have to. We could, like, this guy could just have a method that says like display sensed information, and he could just do it. He could just, hey, you're by this and there's this, and you can see this and you can smell this and you can hear this. He could just do that. I don't know if it's going to be a bad, like we could do something similar where there's just different senses, and this thing says, hey, senses, tell me what you can see in here and stuff like that. We could do that. Maybe for right this second, we'll keep it simple and keep the sense stuff in here. Though we might want to pull that out eventually. All right, let's see. So the game flows like this. Players told they can sense the dark. The player has a chance to perform some action by typing it in. We spent a lot of time dealing with that. Their chosen action is resolved. I think we have at least a high level strategy for how that could work. And then the loop repeats. I think that's pretty easy. Most rooms are empty and there's nothing to sense. Okay, that's done. The player is in one of the rooms, so we've already accounted for that, and can move between them by typing commands like move north, move south, move east, move west. I think we've already accounted for that too, that this guy's going to get that input from the console window and return one of these different actions that this guy will then tell to run. The player should not be able to move past the end of the map. I do think, let's add that here just so we don't forget. Ensure we don't leave the map. So make sure we stay on the map. And the room at 00 is the cavern entrance. The player should start here. The player can sense light coming from outside. So we already said we're gonna actually let the main game here deal with displaying that text of like you're in the entrance room. You're in the entrance room. What do you see? And being able to tell that you can see light coming from the entrance room. So I think that's mostly covered, other than how do we know in this case where the entrance room even is? Like how are we going to represent that in this mixture of classes? And I don't think that's the job of any of these actions. I don't think that's the job of this player input, nor is it the responsibility of this. We could have this guy keep track of which room, to say like to have like a row and a column that is the this could have a row and a column that is the entrance room location. Alternatively, this thing could just have like keeps track of the rooms in the world. Like so far, this guy doesn't really have much in the way of responsibilities. I think it makes sense for him to knows which rooms are entrances. So I think he should know. I think that responsibility should be here. Though I will say that at this point, my best guess for how we could represent this would probably be an enumeration. So each the rooms themselves don't change. Like the entrance room, the entrance itself can't shift around. And I will say that let's suppose that it could. I might like this player class. It represents something movable. So if the entrance were something that could shift around, I'd probably do it more like this. I'd have a separate class over here, and this guy would know about it. In this case, the entrance room and also the fountain room, those don't shift around at all. So I could imagine us making an enumeration and just making it that simple that it's just, it knows which, here's, so basically we could have a 2D array of rooms, and each of them will either be one of, that enumeration, either empty, entrance, or fountain. Another possibility though that we could do is we could make the rooms kind of like what we did up here. We could make the rooms a class. So we could have a simple we have like a base class that is a room, and then from that we could have a fountain, like derived from that we can have a fountain room and an entrance room. One of the things that I do like about that, so just thinking this through. Well, I mean, let's stick with the enumeration for a second, but in a moment, I will give you a reason why it maybe makes sense to have classes for that, and that might be like immediately. Let's see. So the room at 00 is the cavern entrance. So we do need something that's gonna like set up the game. So I'm gonna got a lot of stuff going on here this time. So I'm gonna do this. I'm gonna make this be program. The program class are like the main method. And this I'm going to have set up a new game and run it. So this thing's going to start it. He's going to make a new one of these. I am going to squeeze these in a little bit more here. And let's see. Where should I put these? Maybe I'll stick them right over here right now. I'll keep this close by it. Yeah, so this guy will create one of these and run it. And so he'll have the responsibility of somehow getting this game into a specific state that has the fountain at 0, 0, or sorry, the entrance at 0, 0, and the fountain at 0, 2. All right, so now we're the let's see, the room at row 0, column 2 is the fountain room containing the fountain of objects itself. The fountain can either be enabled or disabled. The player can hear the fountain, but hears different things depending on if it's on or not. So some of that stuff is about sensing, which we've for now said we're just going to keep that right here in this Fountain of Objects game. But then so the player can hear the fountain, but it hears different. So like there's this state about whether the fountain is on or off. And something needs to know that. And I think there's I don't think so. I'm going to rule out a few things really quick here. I don't think it's the responsibility of any of these actions or the player input to track, to know the official state of the fountain. I don't think it's the player's job either. I also don't think it's this guy's job. So we could put that responsibility in here to just know, whether the fountain is turned on or off. We could put that here to know, this thing could just keep track of if the fountain is on or off, and that could just be a simple property: is fountain off, on, or something like that. Nice and simple. I think that could make a lot of sense. A lot of the game logic lives here. This is I would say it would make more sense here if it were like a general purpose map thing, but it actually is. I don't know. I think it could go here and be fine. I think I'd lean more towards sticking it here. So that's one possibility, is we could say, didn't mean to move it, got the wrong thing selected. It's we could say, knows if the fountain is on. Like I said, I actually think that of all the things, that's the simplest solution. That's the least amount of code that we could do and make this work. However, imagine a slightly different. In this case, we've got one fountain and it will either be on or off, and that's the limit of all of the state that we've got. But imagine if all of these rooms had more complexity. For example, imagine if there were multiple fountains. Imagine if this game had you had to explore the place and turn on 4 different fountains to turn on the whole thing. Something like that, where there's the rooms themselves, that state then I think makes more sense to belong to the rooms. But that's not really this. And I think, and the enumeration that we've been talking about, I don't think really captures that. You can't, if all that we've got here is an enumeration that's either fountain, entrance, or empty, then we don't have the tools in place. That doesn't give us the flexibility to also include metadata about whether any given fountain is on or not. So the alternative here would be something kind of like what we did up here. We could have a room base class. So this represents the concept of a room. And then down here we could have, empty room, which this doesn't, this thing here actually does not need anything other than this derives from room. And let's see, what else do we have? So then we have an empty room, but we would also have an entrance room, which also I don't know that this has any specific responsibilities either. But this one here, so the fountain room, this would, oh man, it's a whole lot easier to just recreate the card than it is to try and get that text back in there. So this thing could tracks whether the fountain is on. In which case, this guy doesn't need to do that. So in our specific case where there's only one fountain, it's not unreasonable for this guy or maybe the map to keep track of that important like state of the game. If there's any chance that we're going to have multiple rooms or anything like that, it very quickly shifts to we should just have a class that handles that. So it could look something like this. And I think even with all the expansion challenges, we never end up with anything more than that. My cat came to visit. He's probably gonna stand on the keyboard. Sorry, I'm making a space for my cat. Okay. So let's see. So maybe let's go with this plan though for now. That there is, we'll make room classes for each of these. I think these are going to be. I think all of these are actually going to be super simple. In fact, these could potentially all be records. Like we could make them that simple. We'll see. We'll see how that goes. But anyway, so it could be that. So now this is gonna have to have as a collect. So this would have a 2D grid that has references to rooms, some of which are empty, some of which are entrance, some of which are fountain rooms. And one of the things I like about this is it's also still quite easy to when we add in pits, or if you come up with your own clever ideas for other types of rooms to add it, it's just a matter of adding in a new class derived from this abstract class. Okay. Let's see. So I think we've covered all the stuff for fountains, and now the player wins by moving to the fountain room, enabling the fountain of objects moving back to the cavern entrance. So somewhere we got to check win conditions, and I think it makes sense for that to just be here. Check for win loss. Like I said, there's no right now what we've got. There's no way to lose, but I think those are going to go together whatever we do. So, and then this says use different colors to display the different types of text in the console window. Well, I'm not gonna put that into here. There's not one class that's responsible for all of that. An example of what it might look like. Okay, so there's quite a bit there. I mean, we are talking about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, at least 12 classes. And I think there's probably a reasonable chance we're going to end up with a few little like peripheral things, maybe some records for like a location, maybe like we've done in the past, or some enumerations. Like this probably isn't all of it, but this gives us the beginning point of what we're going to have. So I'm going to move this to the other screen. So take a mental snapshot of what we've got here. So again, let's kind of just run through this really quick, high level review. This guy, which is our main method, is going to start the game. So he's going to make one of these. And this guy's kind of the beating heart of our stuff. He is going to, he knows where the player is at. And he knows he knows about the map, which knows about all these rooms, which can be of different types. And we'll probably use inheritance to handle the different room types that we had talked about an enumeration, which might be simpler code other than we need a different, if we did just use an enumeration, we'd need to find a different home for knowing if the fountain is on or not. And then there's this mechanic in here of how is this game going to kind of like step forward? Like, how does it know what action to pick? How does it know what senses to display? How does it know what the user wants? So we've said that the sense stuff we're just going to handle in here. The what action the player wants, we're going to send out to here, and then it'll make one of these two, which again we're going to use in here. Well, we're going to use probably an interface, make two implementations of that interface. So this when it's that time, he'll say, hey, what do you need to what action should we do? He'll go to the console window and say, well, hey, human, what should we do? What do you want to do? And if the human enters game garbage, he'll say, no, that's garbage. We got to do something different. And eventually he'll say something like move north. And then he'll say, oh, the player wants to move north. So, well, he'll say, here's the action the player wanted. And then this guy will say, okay, whatever action you are, I have no clue what you are. I don't even care. But do your thing. And here is access to essentially I don't know about the entire game. But they would have access to the player, and they should have access to the map and all these rooms in here. So they'll be able, like any of these things, will be able to see anything this guy provides, which I think will be all of this stuff here. The player, the map, which from there you can get all the rooms. And then they will execute it, and then so that's well, at least part of the resolving it, and then check for win or loss. And then if we won, then that we end the thing and we're done. Otherwise, we loop around again and do it again. All right. That's the high-level view. I'm going to skip this off screen, but I'll basically keep using this, and I might drag it back on the screen for random commentary here and there. And we did start doing this, so I'm going to delete all of this again and start from scratch, more for reals this time. So when it comes to working on these classes, I tend to start at the bottom and start as simple as possible. So the bottom of the stuff we had, the stuff that everything else kind of builds on, we had talked about having a room class. So let's just see where this goes. We did call this abstract. And we didn't give this any responsibilities besides being a room. Now, one thing I've seen people do is they'll put in the room the location that it's in. In all of the design work that we did, we didn't specifically see a scenario where that was strictly needed. That doesn't mean it wouldn't be useful. But let's deal with that later, because the map is what's going to know what location the room is in. And as far as a fountain room is concerned, the fountain room, for example, won't care where it fits in regard to everything else necessarily. So maybe that's good enough for now. And then we just need to do something like this. So we've got these empty classes, which maybe there's another, like an empty class is usually a sign that something weird's happened, something's gone wrong with the design. It isn't always a red flag, but it's maybe a yellow flag. It's maybe something to be slightly concerned about, but not necessarily problematic. So both of those are empty because we didn't have anything specific that we wanted to do. But then the fountain room did. So this has a public bool is on. Maybe that's all it is. I think we're okay letting this be settable from the outside. Our actions would need the ability, like in order that there is that enable fountain action, it would need to be able to find this room and set this to true. So I don't think it's unreasonable to have a public setter here. A lot of properties don't have, a lot of auto properties. Well, yeah, anyway, I think that's an okay design. I think that covers all of our rooms. But so now let's move up one level and have the map class. And we know, so I'm going to make this private. We know we need a collection of rooms. That's a 2D grid. And I'm just going to go ahead and make this a 4x4 thing. And let's talk through this. So somehow we've got to create the, well, all right. Somehow we had to set up the map. And the way that it was set up originally was, I mean, the way that it's described is the entrance room is always a 0, 0, and the fountain room is always a 0, 2. So we could just set those up directly here and then set everything else to be an empty room. So you know what? Let me see. Yeah, so somehow we got to set up these rooms, and I think that's, maybe it's something like this. So make everything, so a new 4x4 room, and then make everything an empty room, and then we'll come back and say rooms at 0, 0 equals new entrance room, and rooms at 0, 2 is new fountain room. Now, one thing I wanted to check is the fountain. Let's see. So a bool's default value is off. So this will default to being off, which is what we want. All right. So you could make an argument here. Like I've made an empty room for 0, 0, and I made an empty room for 0, 2. When I could have come in here and just said, well, if it's 0, 0, then do new entrance room. And if it's 0, 2, new fountain room, else new empty room. Could have done that. This creates 2 extra empty room objects that then get immediately thrown away. But when it comes to garbage like that, those extra rooms are going to get garbage collected pretty quickly, and I'm not worried about the memory that we used for it because it'll go away and we don't have to do anything about it. So, and that just makes this code super simple. So let's say that's sufficient for now. So we've set up the room, but just by saying new map, you'll get a room that looks like the official map. And is there any, well, okay, so one thing this does need is it needs some way for the outside world to, this is saying we can make that read only, and I like that idea, so let's do it. This is saying, so we need some way for the outside world to be able to get a room, public room, get room at row, column, and then we can just say return rooms at row and that row and column. Actually, let's switch this over to an expression body. Okay. Now, one thing we could do right now, this map class is responsible for setting up like the entrance and fountain room. We could make a set room method that would allow other people to, like, maybe we move this out of here. Maybe we create a new room that's a specific size and let the rest of the world deal with putting meaningful non-empty rooms in there. But anyway, that's what we've got right now, and I'm okay with it. There is the possibility, like, well, we'll deal with that. I was gonna say that, like, right now we've hard coded everything to be 4x4. We've hardcoded everything to be 4x4, and I'm mostly okay with that. But what I'm okay with this guy just treating everything as a 4x4 room. I don't want the whole rest of the program to assume that this is a 4x4 thing. I want to give people the ability to like I want this guy to be able to report to everybody else what the size is. So I'm actually gonna come down here. I'm gonna make an int public int width, or maybe I'll just do columns and just always return 4. Public int rows, always return 4. So as far as somebody who uses this map class goes, they won't just assume that this is a 4x4 world. They'll ask the map for how many rows or columns there are. And but the map class right this second does not support, like, on the insides, its insides only actually currently supports a 4x4 thing. And that's okay for now. So we can revise that later if we need to. But as far as this challenge is described, we don't actually need anything but a 4x4. So like I said, I'm putting this in here so that the rest of the world, we don't have like 4s all over inside of every other class as well. And we could go a step further here. We could even do this. This is probably a big improvement. There. So now, in theory, we actually could change the size here really quickly. Like, we made this an 8x8 world just by typing in an 8 there. The catch would be this stuff. This stuff assumes that it's at least 1 row by 3 columns. If it's anything less than that, this line in particular would blow up on us. So that's probably an improvement, though. I like that. So let's go with it. And let's see, what's our next step? So we've got all the rooms, we've got the map. We do need a player class. And he needs to know yeah, so he needs to he has know where the player is at. So this could be, we could do something like this: public int row. And again, I think we want him to be settable too. So he could do that. He could just have like a row and a column. I feel like this is potentially, like, that location is a potentially meaningful concept. And maybe it makes sense to just make a record location that has a row and a column. And then maybe this guy, maybe we keep track of that all in here, public location, like that. We'll start them at 0, 0. Yeah. That's arbitrary. It happens to be where the entrance is. So we may not need to do anything fancy to account for that. But in theory, this guy, he should not just be placed at 0, 0, but he should be placed wherever the entrance room is. So ideally, he would specifically get set up to be at the entrance room. Let's see. So, and then actually, like in this case, we can make an overload here that's public room get room at a location. So we could add that overload so that we can use a location as well as just a direct row and column. All right, we are making progress here, and it's time to get to sort of the meat of the thing and make the top 10 objects game. And so this needs a way to run the game loop. But he also needs the map and he needs the player. And let's make those, because I think because other things are going to, like the actions are going to need that. So let's make properties for those. So public, player, player, so that can tell us where. Actually, I don't think we want people to be able to set a different player, though we're okay with them changing the player's location. So as I'm thinking of it, like given that this player class only has, and as far as we're concerned, it doesn't need anything more than this location. We could, maybe we've over-engineered this. Maybe we've made this too complicated. We could up here, instead of having a player class, we could have we could do, location, player location. Like we could just do that, and then there's no specific class for a player, but we don't. I mean, it isn't anything more than the location. I don't think that'd be bad. Like I said, I think you can make an argument that that's over engineered because there's nothing else to it beyond that location. But I do feel like there's something there's a little more. This is like a meaningful concept that this is a player, and so I think I like having that defined as a its own specific class, even if all it has is this location. So I think I'm going to go back to having a player like that. And then also having the map. So in here, we're going to make the player, we're going to make the map, and we already saw this will create a map with like the default entrance and fountain. And then we just run. So while true, well, for now, we'll say while true, we're going to indicate send stuff. We'll make a method here that's it's an awful name, but we're just kind of laying out some stuff here. We can change that name later. Ask the player, which in this case is the player. This is actually the player input as in how we've defined it. So we also need that. Let's throw that in here too. So public player input. Oh, we haven't made that yet. That's okay. Actually, we don't. This one doesn't need to be public. This one can be private. Actually, if we're going to do that, well, let's just make it down in here. Deal with that one in just a sec. So player. So we'll ask the player for an action, and then we'll say action dot execute passing. This is stuff we had sketched out before. We're going to, so this guy's going to have a public well, what we'll do is we'll make an interface here, public interface. And this will have a void execute that takes a game, fountain of objects game. And this guy will return some sort of action choose action, not get action. I don't actually, as I'm thinking about this, I don't think it would. Well, that's that. I'm just debating in my mind of whether this player needs the game as well in order to do stuff. And in this particular case, I don't think there's a need for that yet. If we wanted to support players of all sorts of types, it would actually make sense, I think, for to hand off the game so that like if there was an AI player, for example, it would make sense for the AI player, in order to make its choice, to be able to analyze the data of the game somehow. So because other if an AI player had just had to implement that, there's nothing they could do but something random, because they get no feedback about what's going on. They have no insight into the world. They would just like they couldn't do anything meaningful. They could walk north until they die or hit a wall, but they wouldn't know if they've died. They wouldn't know if they've hit a wall. They just have no actual insight. And if they actually had um, some sort of feedback on what happened or things like that, then yeah. So anyway, so I think if we were doing something fancier than just what we're doing here, we might need to pass in extra data. In this case, we don't need to. So yeah, we'll ask the player to choose an action, and then we just say action dot execute. We'll pass in the whole game, and let it do its thing. And then, so that's resolving the action, and then we'll check for a win or a loss. So one thing we could do, while not, yeah, so we want to check for a win. So while not has won, we'll just make another method for that. Public, sorry, that one does not need to be public. Private bool has won. And in this method, because it's a part of this class, we do have access to the player and the map. So for example, we can say map dot let's see, player dot location. So map dot get room at the player location. So player's room equals that. So this is the room the player is currently in. If player's room is entrance room, and so if they're in the, so basically the rules are, if they're in the entrance room and if the fountain is on, they have won. It doesn't matter how they got to that point. If the fountain is on and they are in the entrance room, they've escaped with having turned the fountain on, and we're done. So we've checked that first part. If player's room is the entrance room, and so here's the tricky part. Map dot like I don't know where, I don't, like, right now the problem I have is I do not know where the fountain is. So let's do it. Let's do this. If not player's room is entrance room. So if they're not in the entrance room, we know that they have not won. By the way, this is related to pattern matching, which is coming a bit later. This is one pattern of many. I like how it reads, though. I'm gonna leave it like that, even though we haven't covered it. But the code I just had there is the non-pattern version, though in some ways that is still a pattern. This form is a lot older than patterns in C# are, though. It got grandfathered into the pattern type. Anyway, so like I said, I like that the way that is. But that is a simple way to check the type. So if it's not then, and so basically if this thing's type is not the type entrance room, return false. Otherwise, well, we need to find the fountain room. And remember earlier, I'm gonna bring this back over here. Earlier we were debating like we could just stick in here whether the fountain is on or off. If this guy had a property that is fountain on, this code would be really easy. We could say if is fountain on, return true, return false. Like it could be that simple. If we had that property, if is fountain on, return true. In this case, we made a design choice to push that out to the room types. And so in this case, we've got more work cut out for us. And we could do something like we could do something like this. Yeah, hang on. Let me take a step back. So the problem we've got right now is we don't even know where the fountain room is. And truth be told, in this context, we don't necessarily know that there is only a single fountain. There is a possibility that the map contains many fountains. So we could, I'm like I said, I'm thinking through how we could do this. One possibility is we could say, for int row equals, so we could just say, okay, I'm going to walk across the entire map, every row, every column, and I'm going to look for fountain rooms. And if I find one and it is off, then I know we haven't won yet. Otherwise, then if I get through the whole thing and I've not found a fountain that's off, I know we won. So let's write out that code. So for int row equals 0, row less than. We do have map.rows plus plus. This is what I was mentioning earlier, that because we defined this, we don't have to put a 4 here. So now if the map size does change, this code won't have to change, which is a plus. If map dot get room for the row and column is a fountain, let's see. All right, sorry, I just had to check in the book really quick to make sure this is covered. But so it's in level 25 when it's talking about casting and checking for types and all the different ways you can do that. So if it is a fountain room, so we do. I just want to make sure that we had this tool in our tool bag, and we do. It's right towards the very end of the inheritance chapter in the section called casting and checking for types. You're wondering where it is, but if is fountain room, fountain, it's a long name. If we go through it all and it is a fountain room, then if fountain room dot is on, so if we find one that is not on, return false. So if we find one that's not on, we can be done here. If we find one, because we know at that point there's at least one fountain that's still off. Otherwise, we're just going to have to keep going. So that's very deeply nested. I mean, we could do and not fountain room dot is on. Like we could do that. I don't know if that's any better. We could, you know, I mean, we could put this in to another method if we wanted. I think I'm actually okay with it like this. Maybe another thing we could do that might make this line read a little better is we could make another property that is called public bool is off. And we're not going to give this as setter. This is just kind of overlaid on the top of this is on. And now this line here can be that, which is a little easier to understand. I kind of like that. It does mean there's this, you know, two properties there instead of one. But so if fountain room is off, return false. Otherwise, so if we're not in the entrance room, then we know we've failed. If we look through every single room and find that there isn't one, we find that there isn't, then let me start over. Okay. Knowing if we've won comes down to two things. We need to be in the back in the entrance room, and there needs to be the fountain needs to be on. So if we discover we are not in the entrance room, which is this line, we know we haven't won. If we discover, if we look through all the rooms and find a fountain room that is off, we know we haven't won. If, however, we are in the entrance room and we look through every single row and every single column and do not find a fountain room that's off, then we have won. Which technically means, like in this case, if we manage to not put a fountain room into the map at all, the game would be over instantly. Anyway, yeah. So okay. So this is really the first method that we have that I think has a lot of like algorithmic complexity to it. But I think that should work. So, and I think now, so run. So until we've won, then we sent stuff, which doesn't do anything yet. And we get an action from the player, and then we execute it. All right, so we actually have all of our, you know, a skeleton here for everything. We still need to do the sensing thing, and we still need to implement the player input, and we still need to implement all the actions. So we're still missing a lot of kind of random stuff here. But let's go ahead and add in public. Let's make our actions next. So public class, and let's do the move action, which this is an I action. And then we will, yeah. So in this case, move action. So what this needs is a public move action. So we talked about this when we were doing kind of some of the CRC card level design. We could have a move north and a move south and a move east and a move west. That may not be such a bad thing, and maybe we'll still do it. But I think what we could do is a single move action that just has a direction, and this direction is just an enumeration, which we'll throw in here really quick. Public enum direction north, south, east, west. And then when we execute this, then, okay. So what we basically need to do here is this execute method needs to move the player one space in a direction determined by this direction. So let's get the location. And now we need to shift it. We need to shift it by whatever the direction is. And so we could just stick that in here, but I think I'm going to make that feels like a separate task, so I'm going to make a private. So given a location, a direction, we want this method to, given our starting location and the direction to move, we're going to create a new location. And I think I'm just going to use a switch expression here. Return direction to move, switch. And if it's direction.north, then new direction. Let's see. So start.row. Hang on. I'm going to bring up this again because this gives us. Okay. So north is up. So that would be row, one less row. And south is one more row. West is one less column. East is one more column. So use that as our guideline here. So row -1 and start.column. So same column, one less row. Oh, not direction, location. All right, and then same with south, but row +1. And then east is new location, start.row, leave that unchanged, and start.column +1. And west. Okay, so this will create a new location based on the current location and the direction, which now means this code here. So I hope this is becoming clearer. I don't know how often I've called this out, but like for me, like the way this really works comes down to every problem that I have, I want to like be able to work on that problem on its own, independent. So like here's I had this problem of I know where I'm at and I know what direction I'm supposed to move, but I don't know what that means. Like if I'm at some location, I need to move. Somehow I need to like figure out what that entails. And anytime I run into something like that, I will usually go make a method to define it. And then I can, like when I'm working on this method, I don't like the way this is, I don't have to even, there's no other line of code that matters right now. It's just this code right here. And it's just this task of given this start location in this direction, all I need to do is come up with some sort of code that computes the new location given the the original location and the direction I'm supposed to be moving. So this allows me to forget the rest of the world and focus on a very narrow problem. Meanwhile, once I'm done with that, now it's this building block that I've made, this get relative location. And I can use that anywhere I want. Well, anywhere I want that it's accessible. I can use it anywhere I want, and I can just trust that it's going to do its job. And that really is kind of the notion of abstraction. We talked in the book. We talk about abstraction at the level of a class, but I think that concept applies at a whole bunch of other levels as well, including a method. That I can focus on this method and making sure that this method does what it's supposed to do. And then elsewhere, I can just assume that it's working and just use it. So now we're going to, the next location is we just call that method get relative location. We pass the current, we pass in the direction that we were told to move. And now we've got the location that it's supposed to go. In theory, we could say game.player.location equals next. So that is a good start. One thing we have not accounted for is if we accidentally moved off the map. We can defer on that for a little bit. One thing I'm starting to get antsy. It's been we've written a lot of code here and not ran this a single time. So I want to get to that point very quickly. So I'm going to let's do this so we don't forget. I'm going to put a to-do comment in here. Check that this new location is still on the map. So hopefully that will help us remember to come back to that. And now we have at least one action type. So now this player input, we could, like, for example, we could say return new move action direction dot south. Obviously, that's not what we want it to be. But I actually think at this point, if we do one thing in here, if we just say console.writeLine, what did this say? You are in the room at. If that's all we do, we actually have something of a working program. What's going to happen here, though, is we do new. We need our main program. There. Okay, so this is our main program. It'll come in here. It'll start, make a new instance Fountain of Objects game, and it'll call run. And this will loop until we've won. It'll call send step, which will just do the thing we just put in there. It'll say you're in the room at whatever. And then it'll say get an action, which we've always said move south, move south, move south, move south, and then execute that action. So this actually should get the player moving south, and then it'll loop around again. So this doesn't ensure we stay on the board. It's always going to move south. But I think at this point, so the thing's probably going to just march south and then be done. But like I said, we haven't ran this at all yet, and it's probably time we do. You didn't see all of that. So you're in the room at row 0. So yeah, it marches down here. I actually, in my head, I had expected it to just like keep going. But yeah, it threw this exception. Our program's crashing. It's dying. And that's because we went too far. Okay. So. But the loop is like, it seems to be working. We've got a lot of little things to sort through still, but we're making progress. So let's go take care of that. So in this case, it's this to do right here. So we need to figure out if this thing is on the board or not. So if next, so it we could say if next dot row is less than 0. We could put that check right here, but I like, again, kind of like we were talking about with this get relative location. I like the idea of hang on a sec. I don't know if that is a Windows thing or maybe it's got to be a Windows thing. So I don't know if you saw my screen fade out, and it's just because it got to be nighttime, so it faded. So I just turned it off because I don't need that for the video. Anyway, where was I? Yeah, so we need code somewhere in here to make sure that we stay on the map. So it'd be nice to just have a method that we can just say, is this on the map or not? And I feel like that belongs to this map class. So we didn't call this out in our design, but I think we can just have something in here that says public bool is on map, and we have a location. And we put our code in here for that. So now anybody else can say, hey, map, is this location a meaningful location or not? And this can say, so if location.row is less than 0, return false. No, you need to have a negative row doesn't count. If location.row is greater than or equal to rows, return false. So if we've gone too far down, then we're not on the map anymore. And same here, columns. It shouldn't be columns, it should be column. All right, so if we've checked all 4 directions and haven't ran into a problem, then it should be good. And now up here we can say if map game.map.is on map where we're expecting to go, then update the location. Otherwise, here we've detected that we can't move, so let's just do like a console right line. You can't move there. All right, so now if we run it, it should march south until it gets to the edge of the map, and then just you can't move there, you can't move there, you can't move there. That's what I'm expecting. Let's see what it does. It's moving pretty fast, but if we just stop it, you're in the room at 3-0, you can't move there. You're in the room at 3, you can't move there. That's what we expected. So let's, yeah. All right, let's deal with the next issue, and that is it would be nice if we could actually choose something instead of it just being south being forced upon us forever. So let's see. Console.writeLine. What is the original? What do you want to do? It's actually right. So what do you want to do? Console.readLine. And that could be null, so let's do that. So and then what we have here is an action that could be null. So chosen action equals. So we'll do a switch. We'll do a switch expression here based on the input. So if it's move north, then new move action, we pass in direction dot north. If they typed in move south, then we pass in south. And same for east and west. And if it's anything else, then we're going to say no. So this action might be null. And if it is, then we didn't pick anything valid. So we should say if chosen action does not equal null. So if we found a good one, let's just return the chosen action and be done with it. Otherwise, we're going to say console.writeLine. I do not understand that. And we'll try again. So let's just make this a do while loop. All right, so we'll do this at least once. Come in here, we'll try and get an action. If we get an actual action out of this, then we're going to return it. Otherwise, we're going to ask them to do it again. We have not handled the fountain case. We need to. But now we should be able to type in. So move south, move east, move east. You can't move there. Something's gone wrong because I should be able to move west from there, right? Yes. We got some logic broken in our... Oh, I wonder if our mistake. Like I just came back to inspect this, and at a glance, this still looks right to me. Like I think we got all of our signs the right way. This is columns. Like it looks correct. So I wonder if our mistake was here. No. So wondering if we had maybe it's in here. Yes, there it is. All right. Let's try that again. Okay. That's working a lot better. So I'm technically in the fountain room right now. Okay. That's one bug down at least. All right, let's see. What pieces of this do we not have? Um, we have not done any sensing at all. Well, other than the you're in this room. So let's do this. Console.write line and get a little divider in there. Not that you need to do that. And then here we can do the different sensing. So sense entrance room light. So we can make a private. This is public, but it actually could be private as well, and should be. Private void sense entrance room light. And then this guy can say if player dot location, if map dot get room at the player location is entrance room, console.write line, you see light coming from the cavern entrance. And then we could also have a sense fountain sounds and have a private void sense fountain sounds. And you could potentially just squish all this up into this method. I don't think that would be so bad. I don't think that's necessarily asking too much of that one method, but it kind of depends. Like especially as we add more stuff, it might get bigger and bigger. All right, so basically it's the same pattern, other than it's is the fountain room. If fountain room, well, I'm gonna just make this a little bigger. If fountain room dot is on console dot write line. I'm gonna copy and paste this rather than type it all out. Else this. So now we should be able to sense stuff as we move around. Good. You see light coming from the cavern entrance. Let's move east. We're not in any special room here, so we shouldn't see light. We shouldn't hear the fountain. So far so good. East, move east again. This should put us into the fountain room. You hear water dripping in this room. The fountain of objects is here. Okay. We don't have the command enable fountain yet. That's the last major piece. I think there's a couple of other loose ends here. But so I'm gonna stick this right here. Public. So let's move on to that class. This is the enable fountain action, which is an I action. So if game.player.location game. Well, all right, I'll slow down a little bit and explain this as I'm going. So location, player's location equals game.player.location. So get the player's location, and then room, player's room is game.map.get room at the player's location. I was going to squish all of this onto one line. If player's room is not. Actually, you know what? Yeah, let's do this. Fountain room nullable equals player's room as fountain room. So, all right. So if fountain room is null, then we can just return. We don't need to do anything except for we can say console.write line. Can't do that command here. You can't do that in this room. Otherwise, we can just say fountain room dot is on equals true. So we turn on the fountain. And now the other piece that we need is right here. If we type in enable fountain, so now we do have the option move east, enable fountain, move west, enable fountain. You can't do that in this room. Move west. And at that point, we've won. Which I think we could say right here, not there. Console.write line. I missed. I didn't copy that. Move east. Enable fountain. Move west. All right. So we have, if I bring this back over here, we've implemented all of these. We did the player input. We did the map. We've got all these room types. We've done this. We've done all that. Yeah, so we've basically done everything, though there are a couple of things we didn't account for. And some of those are use different colors to display the different types of text in the console. For example, narrative items, the intro and the ending. Maybe magenta, descriptive text in white. Input from the user in cyan, text describing entrance light in yellow, messages about the fountain in blue. So we just need to add a little bit of color. And I think that's actually the whole, I think that's it. I think we're actually that close to being done. So this doesn't specify which things, but we could do console dot foreground color equals console color dot white for these two things. we said that this right here should be blue. So we could do blue is kind of hard to read, honestly. At least on my monitor it is. Make that yellow. Intro and exit text. In cyan. Put that there. Let's see what else is there. Input from the user in cyan. There's only one place where we ask the user to do something, and it's in that player input class. Let's do this in I know in some of the other challenges that we've done, like we made like a colored console class and just use that, so that you could just say console.write with some text and then comma color. Honestly, I kind of like that better. I think that'd be an improvement. I'm just at this point, I'm just about 2 hours into this, and I like we put a lot of time into this already. I don't know if I want to. Yeah, so I don't want to. I want this video to end at some point. So, um, I think at that point we've actually covered all of the major objectives of this first challenge. And like I said, it's a big challenge. Like I've seen how many I've probably seen several dozen people's actual implementations of this. I have written it myself several times. I wrote the challenge. You know, I got a lot going for. I've been doing C# for a long time. I got a lot of advantages going for me, and this challenge still took me 2 hours. But again, if you are able to program something of this size, you are doing fantastic. Like it's gonna probably take you more than 2 hours, but if you manage to do what we just did here, then you're in great shape. And if you're watching this video because you didn't, you couldn't do this, and you're looking for some help or some other ways to do things, you are in good company. Like I said, this is supposed to be hard. It's that refiner's fire, that crucible that you have to go through. You gotta work for it. In order to, you can't just read the book and know C#. The book is there as a supplement in your journey for writing C# programs and being able to do this kind of stuff. So, and again, I'll say that your design may have been entirely different than mine. I do think that my version online, I think I remember that these, like I had basically a separate class, kind of like what we did with the actions down here. I had a separate thing for like senses, which I think that's a reasonable choice, and we may end up going like, so we've got several more challenges to do here building on this. But yeah, this is big. This is honestly, this is only a tiny bit. This is only a tiny bit smaller than the final battle. Like I've ended up with about 200 lines of code. You might end up with more, but yeah, I mean, like I said, this is yeah. So to wrap things up, I just want to say that if you are having struggling with this, you're in good company. B, it's it's just the nature of making software and learning how to do this kind of stuff. It will take time, but then take a look at what I've done here, and kind of study it and see the parts that you were struggling with and how I approached it. And then remember the parts of this that you thought, hey, that worked really well. Maybe I should try that. And the parts that you thought I didn't like that, I mean, maybe you didn't like how I did the senses this time. That's okay. Maybe you didn't like how I did the rooms. Maybe you'd prefer the enumeration, which we had talked about earlier, or whatever it is. Take the remember the parts that you like, the things that help you get unblocked and allow you to move forward, and the things you don't like, you can not worry about them. You can skip them. I think I could find probably 20 things that I would like to improve about this if I went through it and tried to find it. So there's definitely room for improvement in this. But then give yourself a little bit of a break. Go watch a movie or something, and then come back and try it again. If you got 20, let's say you got 20% of the way through this and got stuck, and you're just like, I don't know how to do this. I've got this piece and this piece and this piece, but I don't know how to make these work together, or I don't know how to make this other piece. I'm just stuck. Take what you've got here, and like I said, take the pieces that you like from this and apply them. Like, give yourself a little bit of a break so you're not just like literally copying and pasting what I'm doing as I'm doing, because I don't think that's a very effective way to ensure that you're learning, or to even cause yourself to learn. Is just copy paste, copy paste, copy paste. Because that's just kind of going through the motions. Rather, like I said, learn the things you want. Give yourself a little bit of a mental break, and then come back to this in a few hours or tomorrow or something like that, and give it another try. And again, I can guarantee you will end up much better off than you did your first attempt. And if you have to repeat that process a couple of times, then that's fine. And again, if your code isn't as quote unquote beautiful as mine, not that I'm saying this is especially beautiful, but if you ended up with 800 lines, you're like, oh man, why is don't I wouldn't worry about that. Like, again, in that case, like, take the little bits and pieces, like, oh, that was clever, I should do that too, and do those next time. But don't stress over, my code ended up really complicated, I gotta come back in here, I gotta make this perfect. Like in truth, if you are able to use C# to make a program of this size, then you are in great shape, even if you know that there's like lots of room for improvement. So anyway, I've that's probably enough about that, and I think I've said everything in there more than once now too. So I'm gonna end this video, and the next video will go through at least some of the expansion challenges that build on this. Each of those individually are much smaller than this was. They should be, for the most part, fairly minor enhancements on this. And like I said, even though the book says you don't have to go through all of them, we will in the next video. So, but that's it for now, and I hope it was helpful. I will see you next time.